Hi and welcome to Computing Fundamentals 2. I am Dr. Basil Magable, an assistant lecturer here in DIT. In this module, we are going to focus on two main topics, graph theory and computational trees. You will find the graph theory an interesting topic to study as it will help you to understand further modules in this course, like algorithms, databases, computer networks, and data analytics. Graph theory is a science that helps us to answer some serious questions related to real-world problems. One application of graph theory is the Touch ID found in most smart mobile devices. Using a graph theory, the Touch ID verifies the user fingerprint and allows access to the mobile. One possible way to perform such Touch ID identification is to use a technique called graph isomorphism to compare the fingerprints of the user. That's why the device asks the user to provide as much as possible fingerprints from different angles. Software component uses a graph theory algorithm to authenticate the user's access. Another problem solved by graph theory is route planning for commercial airlines. Using weighted graphs, airlines are able to identify the shortest path or the cheapest path between two cities around the globe. In similar way, can we travel along the roads of a map starting at a city and returning to it while visiting each city exactly once? Considering the Irish road map shown in the map, if we start our journey at a new port, is it possible to travel each road exactly once and return to new port? As you can see from the map, there is many paths we can take, but which one is the shortest or which path is the fastest? All these questions are going to be answered using a graph theory. So this module will cover the definition of graphs and their models. Also, we will understand how to represent them and how to find if we have two graph isomorphic or not. Graph isomorphism is an interesting topic to study. Most importantly, we will study the Euler and Hamilton circuits. The graph theory topic will finish by describing graph coloring. In the second topic, we will study trees and its applications, and we will finish the course by describing an interesting technique called tree traversal. The online lectures will cover the concepts and theory of a graph. We will use the online tutorials and labs to see those theory on action, and we will use Sage Math to build and test those theory. Google Classroom is used as a learning environment. It will provide a centralized portal for all online videos, tutorials, and assignments. You should receive an invitation email to join the class. Otherwise, you could visit Google Classroom using the URL and join the class using the code above. Also, there is a handy and useful app you could download to use Google Classroom for iOS and Android. I will explain in this video how you can join Google Classroom. So to join the Computing Fundamental class, go to Google Classroom and then click on the sign button. Then click on the plus button to add the course using the code provided in a previous slide. Make sure to use the DIT email address. The Classroom app allows you to view the shared folder, lab, and lecture notes. It also allows you to view the course calendar and Google Calendar. In Google Calendar, you will find all information about future events, scheduled tutorials and assignments due date, and etc. The to-do list allows you to see all pending tasks that you need to take care of them. For lab and tutorials, we are going to use Sage Math. A tutorial about installing and running Sage Math is provided at this link and in a Classroom page. Another option is to use Sage Math Cloud, which have a new URL called cocalcs.com. google.com. 1 to 3 lectures are going to be published weekly on Google Classroom. We will run an online tutorial every week except the weeks that we have a traditional class and labs, as shown in the schedule above. For online tutorials, we will use YouTube Live, where you will find all lectures and tutorials in the above channel. Date and time of the live module is going to be assessed using continuous assessment 30% and final written exam 70%. The exam has 4 questions where you need to answer 3 questions out of 4. This assessment is designed to promote active learning and a student-centered approach. For this aim, we will run 4 labs worth 4% of the total CA mark. Also, there will be 2 assignments. The first assignment worth 10% of the CA, and you will be given this assignment in week 4. The second assignment worth 15% of the CA, and it will be available in week 7. To promote reflective learning, a survey will be posted on Google Classroom and to capture your feedback and suggestions. And it will allow you to reflect on your learning experience on this module. Thank you and welcome again to Computing Fundamentals.